I think nuclear power should be part of our arsenal of technologies. It doesn't have any greenhouse gas emissions, and it's quite safe. And you've got to deal with a problem which I always talk about when I give talks to a technical audience, and that's perception versus reality. Perception is that nuclear does a lot of damage and kills a lot of people. Reality is that nuclear is safer than coal, safer than oil, safer than natural gas, safer than wind. No, excuse me, safer than photovoltaics. Not quite as good as wind. So what's the big deal here? The big deal is Fukushimas happen very rarely, but they are big and they occupy the headlines. So perception versus reality, I talk to people also about transportation. So in transportation, if you look at fatalities per passenger mile, the safest form is air travel. Now, air travel, you get an airplane crash, you get headlines all over the place and lots of worries and lots of money spent. The least safe is motorcycles. Now that doesn't surprise me. But the second in the list is walking. If you're a pedestrian, you have less risk of being killed than if you're a motorcycle driver, but you've got more than if you're riding airplanes, and you've got more than if you drive a car. We don't regulate walking. We don't mandate that everybody go around in armored suits. Perception versus reality is a big issue, and in the nuclear, I tell people, you're not going to get around this. Just remember, if people feel they have no control, and if people think that something big and scary is going to happen, they're going to worry. They're right to worry. But I wish they would worry in a more balanced fashion about the other things that are doing even more damage to them than nuclear. Think of it. Coal, much worse than nuclear power, including all the nuclear accidents. So that's going to be a tough one. Now, Fukushima. Let me come back to Fukushima. There are lessons being learned from Fukushima. The investigation is not complete yet. First lesson learned is that the regulators and the promoters have to be at arm's length. We learned that in 1974 when our Nuclear Regulatory Commission was made separate of the Atomic Energy Commission. It's independent. The Japanese have only just learned that. They've just announced that they're going to make their regulators independent. India announced 2 weeks after Fukushima that they were going to make theirs independent. We're not perfect. Think of the Gulf oil disaster. The Gulf oil disaster is an example acknowledged where the regulators in the United States were much too cozy with the promoters and much too cozy with industry. Now they've taken what I call a baby step. They've kept them both in the Department of Interior, but they've separated them. I would have moved the regulators out into something like the Nuclear Regulatory Commission. There are 2 other lessons that are being learned from Fukushima right now, and there probably will be more later on. One is the time that you have to survive what's called a complete station blackout. That means there's no external power available to the site. Every reactor has stuff to take care of complete station blackout. They have batteries, and then they have emergency generators. The other thing is that there's going to be a reevaluation of simultaneous problems. In Fukushima, as far as we know now, at the earthquake, everything worked just right. The reactors shut down, the emergency cooling systems came on, the generators all ran, and then 50 minutes later, the tsunami hit. It came over the seawall. They'd put all the generators in the emergency generators in the basement of the generator building. They were flooded, they died, and there you were. 2 disasters, and they didn't have a proper defense in depth. That's going to be reviewed too. What more is going to happen is going to depend on the details we'll find out. I would say what's going to happen to the nuclear renaissance is it's going to have a short pause. And I say only a short pause because the big construction was going to be in Asia, and it will continue to be in Asia. Countries like Germany baffles me. Germany wants to phase out nuclear. Well, they phased out nuclear once before. And then they phased out that phase out when they decided they needed to do something about emissions. And so they changed their plans, and they didn't shut down all the reactors. Now they're going to shut them down. And the irony in this is when they shut them down, then they're going to get nuclear-generated electricity from France, and then they're going to get coal-fired generated electricity from Poland. That's how they're going to make up for shutting down their nuclear reactors. The state of the reactor business is sort of as follows. What has been built is called Generation 2. That's what's in Fukushima. That's what most of our reactors are. What's being built now in Asia is a combination of Generation 3 and Generation 3 Plus. Generation 3 Plus has had a lot of attention paid to passive systems to handle emergencies, where the operators don't have to push any buttons and nothing has to turn on. Those are just getting licensed. Some of them are being built. What's it called? The European Pressurized Reactor, EPR, is being built in Europe now. Westinghouse's AP1000 is being built in China and is just getting licensed in the US. There's another collection in a new branch of the business called small modular reactors. Not everybody wants 1 gigawatt reactors. Not every place needs things. Not every place has grids that can handle them. So now people are looking at small modular, where small modulator is anything from 35 to 200 megawatts electric. These are claimed to be totally passively safe. That is, you can turn off all the cooling, walk away, and nothing will happen. They will get hot. They won't reach the temperatures where the fuel will melt. You got 2 weeks to go figure out how to get the blowers on, but in that time, you don't have to do anything. Is it true? Well, we'll find out when those go through the Nuclear Regulatory Commission's licensing procedure. That's the claim. I don't have the time or the engineering background to validate it myself. So there are a lot of things happening, and those are built on today's light water reactor technology. There's a whole bunch of stuff that people are talking about for what's now known as Generation 4. And the question for Generation 4 is, what do you want to do with Generation 4? Think of the following. I can emphasize safety, proliferation resistance, cost of electricity, and on and on and on. I can make a list of priorities, and then I can say, okay, let me look at the Generation 4 options, and let's see how they fit this mold. That's going on now. The leading Generation 4 at the moment is sodium-cooled fast spectrum reactors, but that may not be the leading candidate in the future. So I've talked to you about what's going to happen for the next 20 or 30 years. Generation 4, if you look at the deployment cycle, needs a lot of R&D, needs a huge amount of testing before it's going to be available to be built for normal economy's use. And that's going to be 30 years before you're going to begin to see those at the fastest. But Generation 3 Plus and small modulars you can see within a decade.